Hi, I'm Peter Haddock and I'm here outside with Pathfinder behind me, which is a project that Ian Evans here and his engineering team at Perkins have been working on. Ian, this is all about making the best use of advanced powertrain and technologies that you've been developing, and it's all about making sure they work in lots of different applications. This is a big telehandler. Ian, tell me about what you've been doing in here and the carbon savings that you've managed to achieve with the new system.
Sure, so this is the Pathfinder T Handler. So it's originally a 75 kilowatt machine.
Yep.
We've repowered that with a 55 kilowatt diesel engine, so downsized the engine, added 20 kilowatts of electrical power to bring a full system together back to the full working power of the machine. It gives us the opportunity to save about 10% fuel over the original machine and original engine. It also gives some really good opportunities to do some of the things that an EV can do as well. So some electric only running, so we can run this machine, all of its features, with the electric system only for a period of time. So take it into a machine, into a factory, if you can take the emissions away, so a real positive there. And the overall system goes back, when you take it back outside, all the way back up to 75 kilowatts of full system power. So we recover all of the capability that we have for a smaller engine, single fluid system. So a really big opportunity for us.
So what we've got here, folks, is it's a really clever way of hybridizing a solution here to bring in the battery and the diesel combination. Who would have expected a machine this size, looking like this machine is, it's diesel all over for me here, folks, to be able to then all of a sudden switch out and go indoors and run completely on electric. That's the type of clever things people want to do with equipment like this nowadays, isn't it?
Yep.
And it gives people the opportunity to have one machine for numerous applications, and that is critical, isn't it? So how did you go about doing this? Because it started not anywhere near this machine, it started in the clever engineering team, didn't it?
Yeah, absolutely.
Simulation.
Yeah, so this has been a really simulation-led kind of development piece of work. So working together, through remotely through the pandemic.
Wow. Yeah.
We had the key engineering teams working through kind of simulation-led design and simulation-led control development. So getting this system together so we could make sure that all of the engine and the electrical components all work together. They deliver the power as it needs to be. Running through that, so we put that system together and ran it on a testbed originally, and then into the machine. Pulling all of the different strands of that control strategy together through a virtual demonstration originally, then into the testbed, then into the machine, using a very similar set of software. So very limited changes. We went from simulation into the testbed, then into the machine, showing that we can do that really quickly in very quick cycles and adapt that to different machines and different applications very quickly because of that virtual position that we can go in and vary the different sort of applications, the drive cycles that we look at, and we can create then the optimized software to deliver that into a real machine and a real application.
And what's really fun about this, folks, is you'll notice this machine has got a bit dirty and everything because the team have actually been using it as a day-to-day machine on the job site. That is like, all of a sudden, this disappears, doesn't it? And the team go, well, we need a telehandler, let's go and use this one, and we can use it about the site. That is what real-world testing's all about, but it wasn't supposed to be like that. It just happens to be very good at doing the job, doesn't it?
Yeah, so absolutely, it's really here to kind of develop our engineering capability, something that we can show the kind of capability that we've got here at Perkins to deliver new technology, working through that energy transition, to come up with these innovative solutions and show to our customers this capability that we can offer to them, through our sort of engineering teams, through the simulation-led design, through our CMET team who can help build and deliver this machine, that we can create these opportunities for them. And then, as you said, this machine is often, we see it around, it gets used, it's out in the field here.
And I think what's really exciting about this, folks, is you talked there about engineering and technology, but you talked about the energy transition. And what we're seeing now is, people understanding the power of electric, but also people understanding the power now of hybridization on different types of machines. And when we look at that scenario, we've got a smaller engine, so, within this machine. So that takes the weight out of that context. Then we can put the battery system in, but we're not adding huge amounts of extra weight in that whole scenario, are we? Because we're taking away to put back in. And that sort of then configuration is enabled in the same body of a traditional machine, isn't it?
Yeah, so in this we've been able to take some of the space claim away by taking a smaller engine, fit the engine and the electric machine and the batteries in the space claim that we've had previously for the engine and after treatment. Again, yeah, similarly with the weight considerations, it gives us some benefit, and it really gives us an opportunity to optimise this for maybe a position where an EV wouldn't work for some people.
Yep.
It still has some of that productivity, it still continues to give a full system power that we've had before, but it's giving that CO2 saving, it's giving that fuel saving, it's helping us move on that journey towards a lower carbon future.
And also, listen folks, if you're a plant hirer, this is an ideal piece of kit, because you're going to get people saying, I want an electric machine, but I want something to work outside. You know, that's that kind of hybridization. But also what this does is this enables people to take advantage of an EV style approach, and helps us then move and transition those businesses to full EV as well, which we've been talking about earlier today with your colleagues. But for me, what's really exciting about this, folks, is it's the same machine. You know, you just got the benefits of that powertrain, but the added benefits of quietness when you're actually operating. I've seen this running backwards and forwards today. And then, of course, that power differential when you do have the automatic power of the battery system instantaneous as well, isn't it? Changes machines, can change machines in a different way, can't it?
There's lots of things we can optimise differently now by adding that electrical power. That gives us a very instantaneous transient response that you can't necessarily get from other fuels and other systems. So that is a real big benefit, something that we can optimise, and particularly the way we've chosen to use our kind of simulation-led systems and the way we put that together is that we can optimise that. We can choose that to be a feature that we can offer to a customer about how we calibrate the system, how we let the system operate. It can take advantage of things you said, so transient response, quieter operation in certain positions, and again, the fuel consumption benefits we think it brings.
So folks, it's a big thumbs up from me here outside of the Perkins Engine team. The engineers are what makes it happen. But this is a people industry, combining all of the clever thinking with the practical nature of the engineers that built this original machine, and bringing them forward to the future that we need to be on, which is the road to net zero, enabling machines, enabling transition, thanks to you and a very clever simulation team. Cheers.
Thank you.